Okay, two-dimensional word problems. I'm just going to do two examples with you. Tomorrow we'll do three-dimensional and take it from there. The biggest problem is getting your diagram. So let's take a look. The light from a rotating offshore beacon can illuminate effectively up to a distance of 250. A point on the shore is 500 meters from the beacon. That should be from, not form. From. From this point, the sight line to the beacon makes an angle of 20 degrees with the shoreline. What length of shoreline to the nearest degree is effectively illuminated by the beacon? Well, let's take a look. We're going to have to actually test to see if the light from the beacon even reaches the shoreline. So let's see. Here we have our beacon, and here we have our shoreline. Okay? So they're telling us the beacon can illuminate effectively up to 250 feet. I don't want to draw the light from the beacon in just yet, because I want to make sure this triangle exists. So, but they tell you a point from the shore, a point on the shore is 500 meters from the beacon, 500 meters from the beacon. From this point, the sight line to the beacon makes an angle of 20 degrees with the shoreline. So let's just test this. Let's see what the height is, and then we'll see if that height is greater than or less than the 250. Because if it's greater than the 250, it's not even going to hit the shoreline. So let's just calculate height. Sine 20 degrees equals h over 500. H equals 500 sine 20. So h is approximately 500 sine 20. H is approximately 171. Oh, we're laughing. Sorry. It's about 171 degrees, 0.0 degrees, approximately. So, because H is less than the 250, which is less than the 500, we have the ambiguous case. Right? So therefore, that beacon could either be here or here, right? So that's 250, that's 250, right? And there's our height. So let's just do some labeling here. We will call this A, B, C, and we'll call this D. So let vertices A, B, C, D be as shown in the diagram Okay? And what they want is how much of this shoreline is illuminated. Since it's opposite the B, I'm going to call that B. Okay? So let B be the length of shoreline illuminated by the beacon. Of shoreline illuminated by the beacon. The beacon is a light, right? So let's do our job. And we'll calculate that. So let's go here. This is sort of our rough work. We're proving that this situation exists. Here's our let statements, and let's do our solving. So sine of 500, sine of C, we need this angle, which is easy, right there. It's a nice isosceles triangle. They're equal. We can calculate this angle, but it won't be useful for us to calculate B, so we don't really have to worry about that angle. But once we know these two angles, we can calculate that angle, and then we can find B using sine law again. So in triangle DBC, in the big guy, right? Sine of C over 500 is equal to sine of 20 over 250. So angle C is inverse sine of 500 sine 20 over, oh, that shouldn't be degrees, should it? Did I do something wrong? No, that's not degrees, that's a measurement, right? Over 250. Uh-oh. Whiteout time, whiteout time. Yeah. This? This? No, you can go angle C. Angle C is approximately 500 sine 20 divided by 250. Uh-oh, I better use brackets. Shift sine open bracket 500 sine 20 divided by 250 close bracket. That's about 43 degrees. Now, we also know that this angle B will be 43 points. So this is 43.1602. This is isosceles triangle, 43.1602. Now we can calculate angle B. Angle B is approximately 180 minus 2 times 43.1602, which is approximately 93.6796. And I apologize, it's a bit squished. So now we can calculate side B. You can use cosine law, right? You can use sine law. So B, I'm going to bring it down here. I apologize for the squishiness. So B over sine of 93.6796 is equal to 250 over sine of 43.1602. So this is in triangle ABC. You need to communicate, because if I can't follow your work, I can't give you any marks, right? So B is approximately, if you were to calculate that, 250 sine of 93.6796 divided by sine of 43.1602. Syntax error. But anyway, you will get 364.7. So the length of shoreline illuminated is about 364.7 meters. Good? Makes sense? Yes.
Is the 93.68 part of ABC or DBC?
ABC. It's the angle B right there. That is 93.6796. See, I went 180 minus 2 times that, and that gives us that angle right there. Yes?
Because that A is the same angle as C.
Because this is an isosceles triangle. This is 250, that's 250. So you know that angle equals that angle. But you also know that this, using the ambiguous case we taught yesterday, this is 180 minus 43.1602, so that must be 43.
What? 180 minus?
This angle here is equal to 180 minus 43.1602. Remember in ambiguous case, that's how we got the other angle of the other triangle. Or, because you know it's isosceles, if that's easier, you know these two angles are equal. Whatever works for you. Can I explain anything better? All right. The angle of elevation of a hot air balloon climbing vertically changes from 25 degrees, right? It changes from 25 degrees at 10 a.m. to 60 degrees 2 minutes later at 10:02. Okay, so it goes from 25 to 60. There's a difference there of 35 degrees, right? That makes that little angle 35 degrees. Because 25 plus 35 equals 60. The point of angle of elevation is situated 300 meters away from takeoff point. So there's your takeoff point. Here's your hot air balloon rising. What is the upward speed, assumed constant, of the balloon? Give answer in meters per second and round to 2 decimal places. So that's the answer we're looking for. Nice little, wouldn't that be nice on a test if they gave you the answer you were trying to get?
Oh, that'd be so nice.
Yeah, that would be awesome.
Do that at work. See, just like, but tests are not there to like,
Yeah,
to give you a bad mark. Tests are meant to test your knowledge, and if you know the answer, you can see that if you know it or not.
yeah. What can I say? So, what do we need to find? If we want to find the speed with which this balloon is traveling, what do we need to calculate? The velocity, and then when you calculate velocity, how do you calculate that?
Distance over time.
So we know the time. We know the time is 2 minutes, right? So that we need the total distance and we need this distance. Okay. So let's find h1. How are we going to find h? It's a right angle triangle. That helps. So tan 25 degrees equals h1 over 300. h1 equals 300 tan of 25 degrees. And h1 is approximately equal to 139.8923. Now we're going to calculate, we know this is 60, so we're going to calculate this distance, h1 plus h2. So tan of 60 is the big angle, so we need to compare it to h1 plus h2. Tan 60 degrees is equal to h1 plus h2 all over 300. So h1 plus h2 is equal to 300 tan 60 degrees. h1 plus h2 is approximately equal to 519.6152. So now if we know h1 and we know h1 plus h2, we can now calculate h2. So h2 equals 519.6152 minus h1, 139.8923, and that's all approximately, right? H2 is approximately 379.7229. So this distance here is 379.7229, and that happened in 2 minutes or 120 seconds. So now we can find the speed per second. So speed per second is equal to 379.7229 over 120 is about 3.16 meters per second. Can I explain anything better? Any information here that's missing that you might need me to fill you in on? Yep. Sorry? Oh, 2 minutes is equal to 120 seconds, right? Because we know it went from 25 degrees to 60 degrees in 2 minutes. It went from 10 a.m. to 10:02, so it's 2 minutes or 120 seconds. Anything else? Shh. Yes? This bigger angle is 60. The smaller one is 25. This one's 25, and the bigger one is 60. Yes?
How are we going to know from the question that it's not from H1 to H2, that it's 0 to the top of H2? You know what I mean? Because we calculated between H1 and H2. Like, how are we...
There won't be any ambiguity. Because you know at 10 o'clock it's this angle,
Yeah,
so it must be this. At 10 o'clock you're there,
yeah.
and at 10:02 you're there. So that distance is traveled within 2 minutes. Like you know this distance was traveled by 10 a.m. and this additional distance went to 10:02.
Okay. That's because I was just wondering, because, like, what if they ask from the beginning, from 0 to 379 meters?
Yeah, I hear you. It'd be worded a bit differently. But I think based on this wording, it's quite clear. Any other questions? You're going to find the test questions are very clear because we're trying to eliminate any issue of confusion. So,
Can we ask if it's like unclear on the test? Can we clear it?
yeah.
Are you gonna clear it? Or are you
If it's something you should know, yes, I will clear it.